Alright, so let's summarize what we observed in the last investigation. If we let c be a critical number of our function f, and f is continuous on an open interval. If f is differentiable on the interval, except possibly at c, the critical value that could be a cusp, for instance, then f of c can be classified in three ways. If f prime of x changes from negative to positive at c, then f of c is a relative minimum. If f prime of x changes from positive to negative at c, then f of c is a relative maximum. And if f prime of x does not change sign at c, it's neither a relative minimum nor a relative maximum. So this is the first derivative test as it makes use of the slope f prime of x. So we're going to make a quick chart of f of x, f prime of x, f double prime of x, and we're going to look at what the corresponding relationships are between all three or among all three of these for positive, negative values, increasing, decreasing function behavior, concave up, concave down behavior. So f of x, if it is increasing, f prime of x is positive. If it's decreasing, f prime of x is negative. So this relationship exists. Now, if the function is concave up, that means that f prime of x is increasing, and that means that f double prime of x, the second derivative, is positive. So we have this relationship and this relationship. Likewise, if f of x is concave down, and f prime of x will then be decreasing and f double prime of x will be negative. And so we have a direct relationship between the function and the second derivative. Another way that you can do this is using the following memory device. So f of x, f prime of x, and f double prime of x. And so we have plus, minus, up, down, concave up, concave down, plus, minus, up, down, concave up, concave down, and plus, minus, up, down, concave up, concave down. And so here we've got the same relationships. If f of x is concave up, f prime of x is increasing, f double prime of x is positive. If f of x is concave down, f prime of x is decreasing, and f double prime of x is negative. Likewise, if f of x is increasing, the first derivative is positive. If it's decreasing, then the first derivative is negative. If the first derivative is concave up, the second derivative is going to be increasing. If the first derivative is concave down, the second derivative is going to be decreasing. So I actually like this one a little bit better, but this chart is one that I've seen all over the place at NMSE and other instructional materials. All right, so let's review this first derivative test. Let c be a critical number of a function that is continuous on an open interval. If f is differentiable on the interval, except possibly at c, then f of c can be classified as follows. Remember, we had three categories, so we've got some pictures to go with this. Now, if f prime of x changes from negative to positive at c, then c is a relative minimum, and we can see we're changing from negative to positive. We have a negative slope and a positive slope. The function itself is going from decreasing to increasing, and so here is our minimum. If f prime of x changes from positive to negative, so our function goes from increasing to decreasing, my slope is positive here, my slope is negative here, so this must be a relative maximum. And here we have a point of inflection where the concavity changes and the derivative does not change from negative to positive or positive to negative.